Primarily, I started out with the hybrid online lecture for the first semester organic chemistry class. I thought it was just far too static. It was just a lot of reading, a tremendous amount of reading. And I took an online course in Java from a professor at UCLA, and it was torture, you know, just reading, reading. And so I said, I've got to make this more interactive. And so I started out with just the hybrid class, but what I found out is that the greatest benefit has been to the face-to-face class. Integrate more realistic and previously cost-prohibitive engagement. I read another article that said many more learning activities are possible in the virtual classroom compared to the real-world classroom learning activities. And so for a chemist, what this means is you can blow stuff up. Also, very expensive reagents and things of that nature, expensive equipment, can be simulated. So that's what I like about that. Another objective is to decrease the labor intensity in terms of the time and effort that's spent receiving lessons, and also flexibility in location. Okay, so another just kind of more specific set of rationale for technology selection. Recognizing and drawing organic molecules or structures is a very fundamental to studying the discipline. And worldwide organic chemistry curricula include the use of molecular drawing software. Now the students will tell you, I can draw that by hand 10 times faster than I can, you know, on a computer. But the thing is that that is a worldwide requirement. They have to write reports, and in those reports they need to draw their molecules nicely and so forth. And it also allows them to learn nomenclature and so forth, and I'll show you that in a minute. All right, now spectroscopy is another portion. It's the study of the interaction of energy with matter, and we can do that in many different ways with many kinds of energy. And so, you know, like you get an MRI, and so there you're getting radio waves pulsed through your body, and you're in this superconducting magnet, and it's telling you about the regions of your body, if there's some anomaly there, you know. And so spectroscopy is very, very important in organic chemistry as well. And so I'm going to show you a little taste of a software that we found that's very inexpensive that allows us to do proton NMR and carbon-13 NMR. And it's a dream. It is a real dream for an organic chemist. All right, so this is ACD Labs ChemSketch. It's a company out of Canada, and they make this free. Back in my day, this software would have cost about $2,000, okay? But they give this away free of charge, and where they make their money is in some of their other products, but they pull you in, they entice you with this one. And so what we do with this, very quickly, I'll show, we draw molecules. All right, now make this a little big to make sure everybody can see. All right, so here's a chemical formula, and then the students learn to take that and make a structural formula from it. All right, so here it is without showing the carbon. I'm going to correct the structure. All right, and I'm going to show that carbon in the middle there. Now it's going to act up. Okay, there we go. Okay. All right, so the students, they learn how to do this. I have an integrity video, a video to show them how to do this step by step, how to download the software, etc. And so here's the structural formula for the molecule. And very, very valuable tool is the naming tool. So nomenclature, I know that nomenclature is probably a bigger importance for you than it is for us, but they have a naming tool. And so what I have, so what you just said was, the name of this molecule is methane. And I have 4 homeworks that they do at the very beginning of the semester. So the first week they do one assignment, second week they do another, third, and then fourth. And by the time they're finished with that, and they do this at home, they know how to name organic molecules. And so they look at the patterns in the names. I don't tell them all the rules. They have to write their own rules. They have to construct their own knowledge. And so by the end of that 4th week, they know the rules for naming organic compounds. And so there's a code. You know, the meth part has a meaning. It means that there's 1 carbon in the chain, and then the aim tells you that all the carbon-carbon bonds in the molecule are single bonds, and you build on that with all different kinds of organic compounds. And so, again, they have integrity video to show them how to use the software, not how to name the compounds, but how to use the software. And they actually have 4 small ones, short integrity videos. And so at the end of that 4th week, then we start drilling nomenclature and quizzes and so forth, so they are responsible for preparing themselves. So then we can convert this form. I'm going to convert it to 3D. And, okay, so here, I don't know if you can see that spinning around here. All right, so there they get to see the shape of the molecule, the way that it actually is. And so they get an understanding of the 3-dimensional aspects of the molecule. And why is that important? Molecules stack on top of each other in particular ways to determine the density. Nature makes molecules in particular ways that they need to understand, and so that's an important tool. All right, and so now I'm going to go back, and I'm going to transfer this molecule. All right, so it's here in wireframe. You might not be able to see it so well. So I'm going to change its form to ball and stick so they can see it in ball and stick form, and they can roll it around and get some ideas about the actual shape of the molecule. And they can measure bond angles and bond lengths. So I'm going to click on the carbon, and then I'm going to click on the hydrogen, and it tells me what the bond length is. And likewise, I can find out what the bond angle is. I can change the color of carbon. Typically, we represent it with black. All right, another thing that's very important when they write reports is the template, or template, however you say that. So here's a template. They can go through and see all the basic carbohydrates and just pull them out. They don't have to bother drawing them. Alkaloids. The lab kit is wonderful. So they can go in here and grab flasks, Bunsen burners, whatever they might need for a lab report, and just plug it right into the lab report. Okay, so this is ChemDoodle, and we use it to simulate proton NMR. NMR is nuclear magnetic resonance, and it's a scary sounding name, but it's the same technology as MRI. It's the exact same technology as MRI. And the reason that the name was changed to MRI was because people are afraid of the term nuclear. Okay, no gamma rays. Okay, and so here I did a sabbatical with the FDA on the NIH campus a couple of years ago, and they had a simulator called ChemBioDraw, and it's very, very expensive. And ChemDoodle is not as great as ChemBioDraw, but for $67 a whop if you want to buy a personal copy, it's not so bad. It's a very, very good software. So my boss bought a license to put ChemDoodle on all of the computers in Chesapeake 309, that computer lab, and then the other computer labs around the campus. And so the students have access. But here's what I learned just about a week ago. My students said, oh, Dr. Houser, we can get that free of charge on our iPads and on our Androids. All right, so we could go into, we could buy this compound, okay, whatever it might cost and whatever hazards it might bring with it. We could buy it and then take it in and run it on the proton, on the NMR that we have. Dr. Raymond Gross, out of his own pocket, bought us an NMR. It does proton NMR and C13. But those machines are all very finicky. They're expensive to run, a lot of maintenance problems, and it takes time to use them. And so here we can just put in whatever compound we want to analyze or look at its spectrum, and then we can generate those spectra. So I'm going to go ahead and generate the spectra for this compound. I'm going to put it up in the corner here. All right, so I'm going to spectrum, generate. I'm going to generate the carbon-13 first. Then on top of that, I'm going to generate the proton NMR spectrum. Might as well generate the mass spectrum while I'm at it. Now the mass spectrum simulator, the mass spectrometry simulator is not that great, but it's fundamental. It's enough. All right, then I'm going to unstack these. All right, so there are all the spectra. And Doing this with an actual machine costs money, you know, when you put it all together, a lot of money and a lot of time. And here we can simulate all these spectra, so students have an endless source of spectra that they can practice on. So they go through and they look at all the features in the spectrum, so they don't know this part, all right? So I'm giving them the spectra, and then they have to pick that apart and figure out what the structure is. So you give them enough information to figure out what the structure is. But when they're at home and they're studying on their own, or when they're in the computer lab, they can generate whatever they want, and they can learn the spectroscopy on their own, learn all the patterns. Go to spectrum, edit perspective, and so here it is. I can expand it and see the peaks a little bit better. Okay, and then something else I can do, I can show the integration, and what that stair step is, I can measure it, and it tells me how many hydrogens are represented by each of those signals. And so that's a very, very helpful tool. And normally you do that on a real machine, and it just takes a lot more time. It takes a lot of time to do that. Now, the beautiful thing is, there's Snagit. So I can go into Snagit, and this is something I drew in Snagit, something else. Let me go back to Doodle, all right, and it looks like it's just the Snagit editor, so let me open up Snagit very quickly. Capture. All right, so I'm going to go here, and I'm going to capture this spectrum, and then here it is. Now I can annotate it. Okay, I can go in here, and I can just label my peaks. So right here, these are my aromatics. So I type in aromatic. So when they're doing a report, they can go in and do this, and when they hand it in, their analysis is there. They just put the word aromatic up above this one. Over here, they put aldehyde, and they just label each peak. And that way I know that they know what they're doing, you know, that they can analyze this. Oh, one other resource that we use is the chemistry webbook. NIST.gov has chemistry webbook. And this is a great resource. And so here, whatever compound I want to see, let's say C7H8O. All right, so here's the molecules that have that formula, that chemical formula. And I'll click on the first one, benzyl alcohol. So for that compound, I can look up the infrared spectrum. We have an infrared machine, but here the students have an inexhaustible supply of infrared spectra that they can practice on. So at home, they're not going to have a machine. So I can go in here, and for exams, I just copy these and paste them into exams. Makes life a lot easier than running all the spectra myself. All right, if you haven't used Soft Chalk, the college provides it free of charge, and it's wonderful. Like when you go to it on Blackboard, so it's in our e-organization for our division. All right, so contents. Okay, so the dean's page, the staff, the departments, kudos, professional development, science news, editor, and fun. All right, and so the dean, for the first issue, she had a statement in there. This one she didn't. For the staff, we've got Math Learning Center. Veronica Stewart has some information in there, so let's take a look at what Veronica put in. All right, so this is what Veronica put in. All right, so she talks about the vision, the mission of the Math Learning Center, what they offer, their hours, and so forth. So she put that in the newsletter and how it works. Alex Wong, new professor in our department. Now, I dare any of you who don't know Alex to find him. He looks like a student. He's in here. He built this giant barometer in Chesapeake Hall, he and his students. And so it measures atmospheric pressure. And this article is about that, and he explains how the barometer... Okay, so my hopes for this technology integration to transform the hybrid courses from being static, you know, self-study, to being dynamic and go to it anytime, 24/7.